Welcome back students. In this video we are going to study about special type of isomerism which is actually shown by alkanes only. And why? Because of the rotation of carbon atoms along carbon-carbon single bond, and these are known as conformations. So we'll study about torsional strain, dihedral angle and eclipsed and staggered conformations of alkanes in this video. Let's start. Conformations of alkanes. Conformations are different spatial arrangement of a molecule that are generated by rotation among single bonds. Actually, what happens that alkanes can have infinite number of conformations by rotation around carbon-carbon single bonds. What is actually what we find in the structure of alkane, that two carbon atoms are attached through single bonds. We can write it in this form also. This is one carbon atom and this is another carbon atom. Now these carbon atoms are easy to rotate along this axis. One carbon atom can be rotated in by 360 degree while one is fixed. So these carbon atoms are free to be rotated along the single bond, and this rotation results in the formation of number of different structures which are known as conformations. Now rotation around carbon-carbon single bond is not completely free actually. It is hindered by a small energy barrier of 1 to 20 kilojoule per mole due to weak repulsive interaction between adjacent bonds, and such type of repulsions is called torsional strain. Conformations are different arrangement of atoms that are interconverted by rotation about a single bond, as we have just discussed. This is, let's say, an alkane molecule. Okay, let me write a ethane molecule in this way. Let's say it is a carbon. It is another carbon of ethane. It has 3 hydrogens, let's say like this, 3 hydrogens. It is CH3, or more accurately, let me write it in this way. A hydrogen, another hydrogen, another hydrogen. This is the first carbon, and the second carbon is this one, which again contains 3 hydrogen. Now there are two possibilities. In this you can see this hydrogen is in front of this, but if I rotate this carbon while by some degree while this one is fixed, I will get a different arrangement in which these will not be in front of each other. So there are number of different structures, spatial structures possible by rotation along carbon-carbon single bond. So this is the first case this is the case in which the two hydrogen atoms are in front of each other, and this type of arrangement is called one conformation. While in this you can see this hydrogen is not in front of these, but it is in between. So this is another conformation. So two different conformations are possible by rotating the carbon-carbon single bond. Now, I have just told you that there are two possibilities. The first, in which the hydrogen atoms of adjacent carbons are in front of each other. This type of situation, like this type of conformation is called eclipsed conformation, in which the two hydrogens encounter each other. The eclipsed conformation, the CH bonds on one carbon is directly aligned with the CH bond on the adjacent carbon, like this. Another possibility is staggered, in which the CH bond on the one carbon bisects the CH bond angle on the adjacent carbon, like this. This is one carbon, this is another carbon, one is here, one hydrogen at this point, one hydrogen at this point, while in next one it would be like one hydrogen here, one here, another here. Now what is happening, this is the angle of one, and this hydrogen is in between this angle, it is bisecting this angle. So this type of structure in which the CH bond of one carbon bisects the HCH bond angle of the adjacent carbon is called staggered. So there are two possible type of conformation, eclipsed and staggered. You can see this one is eclipsed in which the two hydrogen atoms are adjacent to each other. Just they are facing each other, while in this they are not. This hydrogen is bisecting this angle. So this is eclipsed and this is staggered. In this all the carbon and hydrogen bonds are aligned, and in this CH bonds in front bisect this HCH bond angle in the back. Now rotation of the atoms on a carbon atom by 60 degree converts an eclipsed conformation into staggered conformation. Let me draw it once again. If this is, let's say, staggered conformation, if I rotate this by 60 degree, I'll get a situation in which would be like this. So staggered can be converted into eclipse, and eclipse can be converted into staggered by rotation of above 60 degree. Okay, so the next thing is the angle that separates a bond on atom from a bond on the adjacent atom is called a dihedral angle. As we have just seen that the difference between eclipsed and staggered is of 60 degree. So in this case the dihedral angle is 60. For ethene, in staggered conformation, the dihedral angle for CH bond is 60. For eclipse, it is 0. What does this mean? Just you can see that in eclipsed form, one hydrogen is just in front of other. So the angle between these two is 0 degree. So this is the dihedral angle. While in this case, you can see one is here, another one is here, and the angle between these two is of 60 degrees. So this is the angle between the CH bonds at adjacent carbons. This is called, the angle is dihedral angle. In staggered conformation, dihedral angle is 60. In eclipse, it is 0. Now Newman projection. We have seen that it is very difficult to draw the structure of eclipsed and staggered conformation. So Newman projection is an easier way to represent these in 2D. So in this Newman projection, and on representation of the conformations are commonly drawn using convention called Newman projection. Now the question comes, how to draw it? So look directly down. These are some steps. Look directly down to the CC bond end on and draw a circle with a dot in the center to represent the carbon of the carbon-carbon bond. Now this carbon represents the carbon which is in back, and this dot represents a carbon which is in front. The next step is draw the bonds. You have to draw the bonds. These bonds which are coming out from the circle are actually the bonds of back carbon, the carbon which is at back, and those which are coming out from the center of the circle are of the carbon which are in front of the plane of paper. Okay. Next is attach the atoms on each. Attach all the hydrogen atoms, and each carbon has 3 hydrogen in ethane. Now this is the Newman projection simply. So for a staggered conformation, it would be, this is the carbon in back, this is the carbon in front. For staggered, it would be like this, all 3. Let me draw it more accurately so that it will be clear to you. Let me erase them all. So this is the carbon in back, this is in the front, hydrogen, another hydrogen, and this is another hydrogen. Okay, these are the bonds of the carbon which is at front, and these are the bonds of the carbon which are in the back. You can see that the angle is of 60 degrees. So it is a, yes, staggered conformation. In case of eclipse, these will be in front of each other like this. So this is the Newman projection used for ethane. The Newman projection for the staggered and eclipse configuration of propane. If I want to draw the same conformation for propane. First of all, let's slide the structure of propane. It is CH3, CH2, CH3. Let's say I want to write along this this bond, so it would be like this. This carbon which is on back would be like a big circle. The one which is on front would be like a dot. This one. Now the carbon in front is actually attached with a hydrogen, another hydrogen and a CH3 group. Okay. Now while the one which is at back is attached with 3 hydrogens only. So 3 hydrogens coming out from the big circle. So this is the staggered conformation of propene. 1 carbon, 2 carbon and 3 carbon. Similarly, if I want to write the eclipsed conformation, it would look like this. Now staggered conformations are more stable than eclipsed conformation. Why? Because in eclipsed conformation, the 2 bulky groups are in front of each other and they repel. And this repulsion is minimum in case of staggered conformation. So staggered conformations are more stable as compared to eclipsed conformation. Why? Because electron repulsion between the bonds at the eclipsed conformation increase its energy compared to the staggered conformation where the bonding electrons are far apart, just like this. You can see the distance between these are in front of each other, so they will repel more, while in this case there is a difference of 60 degree, so this repulsion is minimum in this case. That's why this one is more stable as compared to this. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of Ask IITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask Experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on Get Answer, and you will be answered within 24 to 48 hours by our experts. So now you know what are conformations of alkanes, what are staggered conformations, what are eclipsed conformation, and how to draw them. We know about the hydral angle, torsional strain, and also how to draw Newman projection for the conformations. In next video, we'll move to alkenes and we'll study about preparation of alkenes. Stay tuned.